Hi friends, good morning. This is Imran Aziz. Welcome to CivTech Simplified. I'm presenting part 5 of Structural Analysis video series in which we will be presenting 25 multiple choice questions, and these questions will definitely help for preparing the for your next exam. These questions have been focused with civil engineering background, and structural analysis elements fundamentals will be discussed. And remember, the correct answers would be highlighted so that you could review them effectively. So let's get started with today's lecture. So far, we have presented already part 1 to part 4, wherein we have shared 100 multiple choice questions. So for today's lecture, this would be question number 1, but overall it's question number 101. If the length of a cantilever carrying an isolated load at the free end is doubled, if the length of the cantilever carrying an isolated load at the free end is doubled, the deflection of the free end will increase by option A 8, option B 1 by 8, option C 1 by 3, option D 2. Remember, in part 4 we discussed that if we double the thickness of the beam, so what would happen with the deflection? So we saw that it was going to be doubled, but it was going to be half. But here in this question, the question is regarding the length of the cantilever beam, which is carrying an isolated load at the free end. Now, if the length is doubled, the deflection of the free end will be increased by option A 8 times, option B 1 by 8, option C 1 by 3, option D 2. So deflection will increase by 8. Option A is the correct answer for this question. Question number 102. If the depth of a simply supported beam carrying an isolated load at, at its center is doubled, if the depth of the simply supported beam carrying an isolated load at its center is doubled, the deflection of the beam at the center will be changed by a factor of option A 2, option B 1 by 2, option C 8, option D 1 by 8. So this deflection would be changed by a factor of 1 by 8. It will reduced by 1 by 8 if we double the depth of the simply supported beam. So 1 by 8 is correct, which is D. Option D is the correct answer for this question. Question number 103. The ratio of maximum deflection of a simply supported beam with central load W and of a cantilever of the same length with load W at the free end is, what is the ratio between between a simply supported beam having a central load W and a cantilever beam with the same length, but the load here is applied at free end? Option A 1 by 8, option B 1 by 12, option C 1 by 14, option D 1 by 16. So yes, D is the correct answer. It will be, the ratio would be 1 by 16. So D here would be the correct answer for this question. Question 104. A cantilever of length 2 centimeter and depth 10 centimeter tapers in plane from a width 24 centimeter to 0 at its free end. If the modulus of elasticity of the material is 200,000 Newton meter per mm square, the deflection of the free end is option A 2 mm, option B 3 mm, option C 4 mm, option D 5 mm. So correct answer is D 5 mm. A cantilever of length 2 centimeter and depth is 10 centimeter tapers in plane from a width of 24 to the width of 0 at its free end. If the modulus of elasticity is 200,000, the deflection at free end would be 5 mm. So D is the correct answer for this question, 5 mm. Question 105. The simply supported beam A carrying a point load at its midspan. Another identical beam B carries the same load but it's uniformly distributed over the entire span. The ratio of maximum deflection of beam A and beam B will be. Remember, the beam A is simply supported beam and it is carrying a point load at its midspan, while beam B is carrying a uniformly distributed load over its entire span. Length of both beams are same and the section is same. So the ratio of the maximum deflection of the beam A and B would be option A 2 by 3, option B 3 by 2, option C 5 by 8, option D 8 by 5. So the ratio would be 8 by 5. D is the correct answer for this question. Question 106. The maximum deflection of a simply supported beam of span L carrying an isolated load at the center of the span, flexural rigidity beam EI is option A WL cube by 3 EI, option B WL cube by 8 EI, option C WL cube by 24 EI, and option D WL cube by 48 EI. The maximum deflection of a simply supported beam of span L carrying an isolated load at the center of the span, flexural rigidity being EI is. So D is the correct option and this is the formula for flexural rigidity. The maximum deflection. This is the formula for maximum deflection of the simply supported beam. So it's D WL cube by 48 EI, where EI is the flexural rigidity, L is the length, and W is the load. 107. The slope of bending moment diagram represents option A maximum bending moment, option B shear force, option C maximum shear force, option D bending moment. The slope of the bending moment diagram represents bending moment. D is the correct option for this question. Question 108. A plane section remains plane after bending indicated that option A axial deformation are neglected, option B axial deformations are accounted, option C shear deformations are neglected, option D shear deformations are accounted. A plane section remains plane after bending. It indicates that axial deformations are neglected. A is the correct option for this question. Question 109. A cantilever beam carrying point load at free end. Option A can fail shear stress at support. Option B cannot fail in shear stress anywhere in the beam. Option C cannot fail in bending stress at support. Option D cannot fail in bending stress anywhere in the beam. A cantilever beam carrying point moment at free end. Option B is the correct answer. Cannot fail in shear stress anywhere in the beam. B is the correct option for this question. Question 110. An increase in load at the free end of a cantilever is likely to cause failure. An increase in load at the free end of a cantilever is likely to cause failure. Option A at free end, option B at the mid of its length, option C at the fixed support end, Option D, anywhere on the beam. So an increase in load at the free end of a cantilever is likely to cause failure at the fixed support end. So C is the correct option. Question 111. The shear force on a simply supported beam is proportional to option A, algebraic sum of the transverse forces. Option B, sum of the forces. Option C, displacement of the neutral axis. Option D, algebraic sum of all forces. The shear force on a simply supported beam is proportional to option A, algebraic sum of the transverse forces. So A is the correct option for this question. 112. The amount of deflection of a beam subjected to some type of loading depends upon. Uh, I will read again. The amount of deflection of a beam subjected to some type of loading depends upon option A, cross section, option B, bending moment, option C, either A or B, option B, both A and B. Yes, it's both A and B. The amount of deflection depends on the cross section of the beam. It varies if the length or the thickness or depth of the beam changes, and it also depends upon the bending moment. So A and B are the correct options. Therefore, D is the correct answer for this question. 113. Which of the following does not fall in the category of displacement method? Option A, method of consistent deformation. Option B, equilibrium method. Option C, moment distribution method. Option D, stiffness method. So moment distribution method does not fall in the category of displacement method. C is the correct option for this question. 114. The maximum slope of a cantilever carrying a point load at its free end is at the option A, fixed end, option B, center of span, option C, free end, option D, none of these. Is the maximum slope of a cantilever carrying a point load at its free end is of course at free end. C is the correct option. 115. Simply supported beam of constant flexural rigidity and length 2L carries a concentrated load P at its midspan and deflection under the load is D. If a cantilever beam of the same flexural rigidity and length L is subject to point load at its free end, then the deflection at free end will be option A, deflection by 2, option B, 2D, option C, D, option D, 4D. So the one beam is simply supported, its length is 2L, carrying a concentrated load at midspan, which is P, and deflection is D. And on the other hand, the second beam is cantilever beam, having a length L and subjected to load P at its free end. The deflection at the free end will be D by 2. Option A is the correct answer for this question. 116. The shear force at a section in the conjugate beam corresponds to. Shear force at a section in the conjugate beam corresponds to. Option A, shear force multiplied by EI at that section in real beam. Option B, deflection at that section multiplied by EI in real beam. Option C, EI times slope at that section in real beam. Option D, slope at that section in the real beam. Yes, it's slope at that section in the real beam. D is the correct answer for this question. 117. A simply supported beam with rectangular cross section is subjected to central concentrated load. A simply supported beam with rectangular cross section is subjected to a central concentrated load if the width and depth of the beam are doubled. then the deflection at the center of the beam will be reduced to, if the width is double, the deflection will reduce to half. We already discussed this question in the last part in some other wording. So it will be reduced to half. Option A is 50%, option B is 25%, option C is 12.5%, option D is 6.25. Yes, it's A which is 50%. Question 18. In a simply spotted beam, maximum deflection exists where? Option A, bending moment is maximum. Option B, slope is maximum. Option C, slope is zero. Bending moment is zero. In a simply spotted beam, maximum deflection exists where? Option C, slope is zero. C is the correct option. 119. The section modulus of a rectangular section is proportional to, option A, area of the section, option B, square of the area of the section, option C, product of the area and depth, option D, product of the area and width. Yeah, it's the product of length and width, so area of the section A is the correct option. 120. Stress may be expressed in newtons. Option A, per millimeter square. Option B, per centimeter square. Per meter square. D, all of the above. So yes, all these are the correct. Stress may be expressed in Newton per mm square, or Newton per centimeter square, or Newton per meter square. So A, D is the correct option for this question. 121. The range within which a load can be applied on a rectangular column to avoid any tensile stress is, what is the range in which load is applied on a rectangular column and the stresses, tensile stresses are avoided? Option A, 1/2 of the base. Option B, 1/3 of the base. Option C, 1/4 of the base. Option D, 1/5. Yes, it's 1/3 of the center of the gravity, or the one third of the base, from the base. So B is the correct option. 122. In rectangular columns, cross section B into H, the core is a, option A, rectangle of length B by 2 and H by 2. Option B, square of length B by 2. Option C, rhombus of length H by 2. Option D, rhombus of diagonals B by 3 by and H by 3. So D is the correct option for this question. In rectangular columns, the core is a rhombus of diagonals B by 3 and H by 3. 123. A short masonry pillar is 60 centimeter by 60 centimeter. It's a cubic section in cross section. The core of the pillar is a square whose sides are, option A, 17.32 centimeter, option B, 14.14 centimeter, option C, 20 centimeter, option D, 22.36 centimeter. So B is the correct option. 14.14 centimeter is the correct answer for this question. 24. For keeping the stress wholly compressive, the load may be applied on a circular column anywhere within a concentric circle of diameter. For keeping the stress wholly compressive, the load may be applied on a circular column anywhere within a concentric circle of diameter. Option A, D by 2. Option B, D by 3. Option C, D by 4. Option D, D by 8. So C is the correct option. Load is applied at anywhere in the concentric circle of diameter D by 4. C is the correct option for this question. 125, and the last question for this video part. To ascertain the maximum permissible eccentricity of loads on a circular column, the rule generally applied or followed is, option A, middle half rule of columns, option B, middle fourth rule of columns, Option C, middle third rule of columns. Option D, none of the above. Option B is the correct option for this question. So B is the correct option, middle fourth rule of the column. B is the correct option for this question. So thank you for watching this video. This was the part 5 of our video series on structural analysis MCQs. Hopefully these will help your civil engineers to prepare yourself for the competitive exams. Thank you for watching.